Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are covering isometric projections and we are in module number 6. So, in the last class we have seen different kind of projection techniques, namely the parallel projections and perspective projections. In that we noted down orthographic projections, oblique projections and perspective projections, where we in detail went with axonometric projections, which are part of orthographic projections. In that try to learn about isometric projections, diametric and trimetric. Then we try to understand what is an isometric projection, a diametric projection and trimetric projection in terms of the inclination angles. On both sides, if it is equal and making 30 degrees with the horizontal, and the entire object we orient in such a way that a cuboid looks like a hexagon. Such kind of projection what we call isometric projection. In diametric projections we have different angles, something like lower than that 30 degrees, here it is 15 degrees, and in trimetric we will have different 3 angles and something like less than 30 degrees and more than 30 degrees. Such kind of projections we call trimetric projections. If a rectangular box is given, to draw these isometric projections, in today's class we are going to learn step by step how to do those. Especially a rectangle, if it is lying on particular plane, how it can be visualized through isometric projections. So, let us take an example, a rectangle. Now, we have a rectangle of size 30 mm in width and 50 mm in length. Let us name the corner points as A, B, C and D. Now, we would like to have projections for this rectangle. The first one, what we are trying to say, there are 3 different kind of projections possible. One we call right hand vertical face is an isometric projection, left hand vertical face, that is also an isometric projections, and the top view of that horizontal face. Now, let us look at these projections step by step. In isometric projections, first of all we have to construct this isometric axis, where lengths can be measured on true scale basis. So, to do that we are going to first of all learn this right hand vertical face. For example, if I have a rectangle and I would like to view it from slightly inclined right direction, the way how that rectangle really looks like, that is what we call right hand vertical facing. So, something like you have a hand, slightly turn, observe it from right hand side, how it really looks like. So, to do that, what we have to do is first construct a horizontal line and draw a 30 degrees line, because for isometric projections 30 degrees line is inclination line is very important. Now, whatever the length AB, the same length mark it as A and B on this isometric plane construction. So, call this one A, B, because we are drawing it on isometric axis, true lengths we will see. So, whatever AB and this AB one and the same. Now, from A drop a perpendicular all the way up. Similarly, drop a perpendicular all the way from B to C. Parallel to AB line with a distance of B to C, whatever the distance BC there, and another BC located. So, draw a vertical line on that, construct whatever BC length we have it on this rectangle, even on the isometric view use the same length. Then use your drafter parallel to this red line, draw one more line passing through that point C. Wherever this perpendicular A line meets this horizontal line, call it D. So, now we have points A, B, C, D. And this is the first isometric view, because we are observing it from right hand vertical face. Similarly, let us construct left hand vertical face. For that, the same procedure we will follow. First, we will draw a horizontal line, then draw an inclined line. With respect to B, we are rotating it. So, name these variables A, I am sorry, this is supposed to be A, this is B, this is C, and this is D. Draw a 30 degrees line, whatever the AB distance we have, the same AB distance we are going to have it. Mark A, B, drop a perpendicular line, name it C. Similarly, drop a perpendicular line, whatever AD length is there, we have the same AD length. Draw a parallel line to AB line, connect it. This is the way we construct isometric view in the left hand vertical face. If it is a top view, the horizontal face, what we are going to do? Draw a horizontal line, draw an inclined line 30 degrees, another inclined line 30 degrees. Whatever the AB length is there, locate the same AB length. Whatever the AD length, locate the same AD length. Drop perpendiculars from B and CD. So, from the top view, we will construct isometric view in that way. Now, let us look at how to construct a triangle and what are those isometric projections. The triangle is A, B, perhaps some one is given with certain inclination angles. It has a base of 30 units and one of the angle is 45 degrees on this side, other angle is 60 degrees. This triangle we would like to rotate it in such a way that isometric view we can visualize it with base 30 degrees. First step for any of these kind of objects, enclose these objects in rectangle. If you are knowing how to draw a rectangle, similarly we measure the other points and align with that rectangle and rotate it. That is the easiest way, which we popularly call as box method. So, first for the rectangle, draw A, B, C, D lines, enclose this triangle in this rectangle. Now, This entire rectangle has to be rotated as a parallelogram with that 30 degrees line. So, the way how we have constructed rectangle AB, draw a 30 degrees line, on that locate AB points for the right face. Now, from B perpendicular line, so B also perpendicular line, from A also perpendicular line, and parallel to AB, draw at a distance of BC this rectangle. So, we know how to construct that rectangle, construct that. So, the steps what we have followed: AB, AD lines, then BC lines, and then CD lines we construct it. Now, for the triangle, from point 1 we have to locate it on the rectangle. Further, what is the distance from C to 1 on that rectangle? Pick that distance. Similarly, on CD line, locate C1. So, use your compass or divider, whatever that length, transfer that length to here, then call that point as 1. Once we know one point and A, B points are known, we can join them. This is the way isometric view we can construct it. Similarly, if we would like to have left sided front view in the isometric planes, first draw a horizontal line. A point we are rotating in that direction. So, draw a line 30 degrees, transfer AB length here, construct the remaining rectangle, BC lines vertical, AD lines also vertical, draw them, transfer 1 to C length here. One can transfer D1 length also in the same way. The way how we transfer D1, we can transfer it there, or 1 C length we can transfer it. Once done, we have this point 1. Now, join A, 1, B to construct the triangle. Now, we would like to have it in top view. How to construct that? So, one of the axes we need isometric thing. So, that means use AB line as one of the isometric axis. On that we can really construct it. For top view, we require one more isometric axis also. For that purpose, use AD lines. So, AB and AD we are rotating in such a way that they are going to make equal angles. So, let us look at that. First, we draw 30 degrees line. Similarly, draw one more 30 degrees line. Name it A, transfer AD length. Similarly, transfer AB length on these planes. Once we transfer that, we know these points B and D. Now, parallel to AB line, draw one more line at a distance of BC. So, we have point C. Now, transfer 1 to C length from C to 1 here. Once it is done, connect point A, B and 1. In the top view, we have that isometric projection. So, all about this isometric projection is, if you have an object, if you are rotating in such a way that it makes equal angles on both the planes, that is the way we have to construct this isometric projections. It can be any complicated object, but first we have to enclose that in a rectangle, rotate that rectangle, one of the isometric axis one has to identify with 30 degrees, then transfer the true length of this rectangle onto this with the perpendicular lines and parallel kind of lines, and locate the points which we would like to transfer it. So, the points of the pentagon 1, 2, 3, 4 and 5, we have to transfer that onto this parallelogram AB, CD parallelogram. For example, whatever the line A1, same A1 line we will mark it, so that first point will be done. Then whatever B2 length is there, or A2 2 length, the same length we use it from A2 1 2. In the similar way, first we locate A1, A2 length, then B2 3, whatever the B3 length we have, same B3 we will locate it. From C4, C2 4, same length we will locate it. Then A5 we will locate it. Once we are done, we have these points joined by lines. Now, the other front view from the right side view, left side view, if we are looking at, rotate AB with 30 degrees inclination line from the horizontal. Once we are done with that, we can locate first point, second point, third, fourth, fifth points by transferring appropriate lengths. In that way. For the top view, the rectangle has to make 30 degrees equal angles on both sides. So, we rotate in such a way that A, B lines, this makes 30 degrees, and similarly AD line also makes 30 degrees. So, we locate whatever the AD length here, same AD length here we will locate it. Similarly, AB length we will locate. Once that is done, we can construct this rectangle. Then transfer lengths A1, B2, B3, C4 and D5 lengths appropriately, so that we will have first, second, third, fourth, fifth points, join them to get the pentagon in the top view. How to do that for a circle? Let us learn that. The first step is always enclose a circle in a rectangle. Now, wherever these intersections are there with the circle, name them as 3, 4, 5 points for the circle. Now, construct the parallelogram or the rhombus on the frontal view. We have seen how to construct this AB line with a 30 degrees, transfer remaining CD lines also, so that we have this ABCD rectangle. Now, obtain the midpoints 3 and 4 of the sides CD and AD. So, C D the point is 3, from D A the point is 4. These points have to be transferred onto this rhombus. For that purpose, the way how we do is measure what is the distance of C to 3 on this rectangle. Because we have already identified C, now use your compass dividers to mark 3 points where 3C here and 3C there are equal to each other on this rhombus. Similarly, D4 or A4 distance, locate it from A to 4, mark that point as 4 and 3. Once that is done, join B to C by a line. Similarly, join B to 4 by a line and join A to C, the diagonal line. Wherever this intersection is happening, call that point as 2 and 1. I repeat. So, join B to that 4th point, similarly join B to 3rd point, wherever it is going to intersect the diagonal, call those points 1 and 2. Use 1 and 2 as centers. So, using those 1 and 2 as centers, measure what is the length 1 3, then draw an arc all the way passing through there. 1 as center, 1 3 as radius, draw a smooth arc which is intersecting point 5. The way how we have located B to connect 3 and 4, similar way one can even construct from D all the way to that end and all the way to this end to track 5 and 6 points. So, once we know that circle arc, draw that one. Similarly, using 2 as center, draw another arc passing through 6. Now, join 4 to 3 by a smooth curve, similarly 6 to 5 by a smooth curve. So, your circle converts into ellipse in the isometric view. Similarly, if we want left side view, we repeat the same process, construct that parallelogram, making horizontal 30 degrees line. In this way, locate AB points, transfer our rectangle and construct the remaining ellipse. So, let us look at that solution. So, construct AB, CD, transfer these data points 3, 4 and 5, 6, locate centers 2 and 1, use radius, join them as circles through arcs. For top view, the same procedure. AB line makes 30 degrees, BC line makes 30 degrees, construct the parallelogram. Then from B all the way to this 3rd point, similarly B all the way to 4th point by transferring 3 and 4 points from this rectangle. Construct these instantaneous centers 1, 2 and then draw the arcs, connect by smooth arcs to get this ellipse. So, in isometric views, your circle when you rotate it, it looks like an ellipse. And in the next class, we will learn about how to do these isometric projections for solid objects. Thank you.